The courageous search for the Titan deep-sea submersible captivated the world.
The debris is consistent with the catastrophic loss.
But amidst this shared curiosity, a chilling question arises. What exactly happens to a human body when a submarine implodes? Imagine handing a 5-year-old child an air balloon and asking her to poke it. In an instant, it vanishes. The same phenomenon happens in reverse beneath the ocean, but much more swiftly. To put it simply, no remains are likely to be found, yet the unsettling details behind this grim truth are enough to haunt your dreams. The term catastrophic implosion has gained even more attention since the United States Coast Guard's recent announcement about the ill-fated Titan submersible. Officials involved in the rescue efforts have discovered the debris, shedding light on the gravity of the incident. Think of an implosion as the opposite of an explosion, where forces from all directions push inward with such tremendous intensity that an object collapses, similar to a soda can when crushed. Surprisingly, even the smallest scratch or dent in a submarine structure can create a weak spot vulnerable to the immense pressure applied by the surrounding water. The implosion happens so swiftly that any warnings would be futile. To understand how that's possible, we need to focus on a crucial factor: pressure. Whether it be a person, a fish, or submersible equipment, when they venture underwater, water presses against them from every direction, applying equal pressure on all sides. At the ocean's surface, this pressure resembles what we experience on land, similar to the weight of Earth's atmosphere at sea level. For purposes of measuring it, this is called 1 atmosphere. As we ascend to higher elevations, atmospheric pressure decreases because of less air pressing from above. However, as we venture deeper into water, pressure increases. This underwater pressure is called hydrostatic pressure, with hydro meaning water and static referring to a state of rest. The more water lies above, the stronger the force it applies. However, water pushes not only downward, as already mentioned, it applies pressure from all sides, including below. We know this upward force as buoyancy, allowing us to float in water. At a depth of just 10 meters or 33 feet, pressure doubles compared to the surface. In fact, for every 10-meter increment, pressure increases by 1 atmosphere. To illustrate using recent events, the Titanic rests approximately 12,500 feet or 3,800 meters below the surface, subjecting it to a staggering pressure approximately 380 times greater than that at the surface, equivalent to around 380 atmospheres or a crushing 6,500 pounds of pressure per square inch. Our human body is not equipped to withstand such extreme pressures, especially when exposed to sudden and drastic changes. Just to give you an idea, our bodies can handle roughly 50 pounds per square inch. However, at this mentioned depth, a person would experience pressures 130 times beyond their tolerance. As a result, the body's various systems suffer immediate and catastrophic damage simultaneously. Our lungs and air-filled spaces in the head become prone to collapse, instantly crushing the body. The air in the lungs is instantly compressed to the size of an earbud's case. That's why deep ocean creatures don't have air pockets within their bodies. In essence, your body's systems, respiratory, circulatory, and central nervous alongside the tissues would be utterly crushed, disintegrating your body into pieces in an instant. Though the outcome is undeniably tragic, there is a glimmer of insight. According to Dave Corley, a former U.S. nuclear submarine officer, when a submarine's hull collapses, it inwardly moves at an astonishing speed of approximately 1,500 miles per hour, or 2,414 kilometers per hour. This is equivalent to 2,200 feet per second, or 671 meters per second. Thus, the complete collapse occurs in just 1 millisecond, or 1,000th of a second. In comparison, a human brain instinctively responds to a stimulus in roughly 25 milliseconds, while a rational response, from sensing to acting, typically takes around 150 milliseconds. That's 25 to 150 times slower than the speed of the implosion. Therefore, the unfortunate individuals aboard the Titan could never have comprehended the unfolding events. It happened far too quickly for the brain to make sense, or even transmit pain signals. However, there's another crucial aspect to consider. Inside a submarine, the air may contain a concentration of hydrocarbon vapors. When the hull collapses, the air undergoes spontaneous ignition, leading to a subsequent explosion after the initial rapid implosion. Temperatures can soar dramatically. In an instant, the explosion engulfs all the crushed fragments, potentially reducing them to ashes and dust. As unfortunate as it may be, this decomposed matter, blending with water, becomes part of marine life. That's why experts and researchers, well-versed in the consequences of catastrophic implosions, believe that recovering the remains of a human body becomes an overwhelming challenge. If you like this video, hit that subscribe button now and join our community. By subscribing, you'll help us create and share even more powerful stories that will brighten our day and broaden our perspectives. Your simple action can make a big difference to our mission. Thank you for being a part of this journey. Subscribe today. Also, we recommend you to watch another of our videos, in which we tackle another captivating story, Bright Talk style, one revelation at a time. The links are here on this screen and in the description below.